three ways to describe an equation. Up till now, we've mainly talked about the slope-intercept form, the y equals mx plus b. In the y equals mx plus b, the m is the slope or the steepness of the line, and the b is the y-intercept. Okay? Now, every equation also has what's called its general form. In the general form of the line, you move everything over to one side of the equation. You get rid of all fractions so that a, b, and c are just integers. And in addition to that, you can always move something so that the a value is positive. So one of the things we're going to do is if I have something in y equals mx plus b form, so this would be y equals mx plus b form. Do you notice that you have a fraction? In general form, there's supposed to be no fractions. Well, what's the opposite of dividing by 3? You could take the entire equation and multiply it by 3. And if I multiply one side by 3, I multiply the other side by 3, it's still equal, right? You learned that in grade 9 math. What you do to one side, you do to the other. So if I multiply everything by 3, can you see that on the left side I would get 3y? And if I multiply the right side by 3 and have to distribute, and when I multiply the 2/3 by 3, the 3's would cancel out because multiplying by 3 and dividing by 3 cancel each other out. That would just become 2x. And when I multiply the 2 by 3, I get 2x plus 6. Then in general form, you need to make one side equal to 0. So I'm going to subtract the 3y to the other side.
I was wondering if you had AAA batteries.
I do. If your batteries run out, you are in charge of replacing them. So I can lend you some just for today.
Sure.
Yeah.
No problem.
Okay. And so we've now changed it to general form. In the general form, you have a number in front of the x, a number in front of the y, a number by itself, and equal to 0. And this equation in green is identical to this equation in blue, but they look different. Where have we seen identical things that look different before? You've seen that in fractions. Do you know that 2/3 is the same as 4/6? They look different but mean the same thing. That equation in the green box and the equation in the blue box make the same line on a graph, but they look different. We times it by 3 because in general form there are no decimals or fractions. And in y equals mx plus b form, sometimes you have fractions. So how did I get rid of the fraction of the 2/3? Well, the opposite of dividing by 3 would be multiplying by 3. That got rid of my fraction. And form number 3 is called the point slope form because it has the slope m and it has one point, x1 and y1. So if you have something in this form, you would know that m is equal to -4, and you have the point 3, 5. Question there? I subtracted, if you would subtract 3y on both sides, right? Because what you do to one side of an equation, you do to the other. Then 3y minus 3y would give me 0. and then I'd have an equation. And whether you have the equals 0 on the right or the equals 0 on the left, both are exactly the same. Do you remember your formula for slope? That your slope is your rise over your run? Do you remember that from before Christmas? The slope is the change in your y values over the change in your x values. And you can find the change in your y values by subtracting them. Like if you went from 8 to 4, well, 8 to 3 maybe, 8 minus 3 would be 5. That would be your difference in your rise. And so you could always find your rise by subtracting y2 minus y1. And you could find your run by doing x2 minus x1. And this equation, the point slope form, is just your slope formula with only one point. If I use my slope formula, for those of you that like to see where things come from, if I use my slope formula with just one point, oops, just the x1 and the y1. That would be my slope formula with just one point. Technically, that's an equation of a line. Another form. We could call this the slope form of a line. But the reason this isn't another form is because if you now multiplied both sides to get rid of the fraction, and you see that if I multiply by x minus x1, it would get rid of the fraction. What would I be left with? On this side, I'd be left with only y minus y1. On this side, I'd be left with m times x minus x1 if I didn't multiply it out. And that is exactly that equation. So the point slope form of the equation is just your slope formula rearranged. Now, all three of these equations have a purpose. The one that you will probably like the most is y equals mx plus b, because we've used it the most, and it is most commonly talked about when talking about lines. But the point slope one is really nice. If you know the slope in one point, you can quickly make the equation and then rearrange things to get it in y equals mx plus b. The general form is probably the least useful right now, but every single equation has a general form, so it's sort of a common way to talk about all equations that you'll learn about as you go through high school. Okay, so what do we do with these? One thing we do is we just take one form and write it as the other form. So, can you see that each of these are in y equals mx plus b form? And you want to write it in general form. So in your head, you tell yourself, okay, general form looks like this, with no fractions. And a being positive. So I look in our equation. Do we have any fractions? No, so we're good there. But do we have one side equal to 0? Not yet. We need a, and a is the number in front of x to be positive. What is our number in front of x right now? 3. Is it positive? Yes. So what I'm going to do is I'm going to move the y over to the right side, and I'm done. Now it's in general form. No fractions. Good. One side equal to 0. Good. The number in front of x positive. Good. Second one, do we have fractions? Yes. So I'm dividing by 2. What could I do to get rid of that fraction? Multiply by 2. And so I multiply the whole thing by 2, which means I multiply the y by 2, distribute the half. When it gets multiplied by 2, will just become 1. So I have 1x, and the minus 3, when it gets multiplied by 2, I get minus 6. now I have no fractions. I need to make one side equal to 0, and I need to keep the number in front of x positive. Is the number in front of x positive right now? Yes. So then I will subtract 2y on both sides. General form, we always write the x first, then the y, then the number. And we're done. You can have the equal 0 on either side. Is that too quick? I need to go back?
Can you go back to the lesson for a sec?
Yeah.
Here's the equals to go backwards. For general form, it's 3x minus y plus 4 equals 0, not 0 equals 3x minus y plus 4.
Yeah, and I said on the equation you can put the equal 0 on either side.
Yeah, just double check.
Yeah. Okay, ready? So change the following into slope-intercept form. So slope-intercept form, the key thing is that the y is by itself. Can you see that we have general form here? If I wanted the y by itself, I could, first of all, add the 3y, so I have the term with the y by itself on one side. Now, technically, if two things are equal, I could either write it like this, 4x minus 6 equals 3y. I did it that way because of how the equation was originally. Can you see that that means the same thing as this? So you could switch it over at any time. Generally, y equals mx plus b, the y is on the left. It wouldn't be wrong if the y was on the right. But just so that it matches up, we'll put the y on the left. Yes?
Oh, never mind, it's negative.
Perfect. Then, if I wanted to get the y by itself, I would need to divide by 3. So that means I have to divide the left side by 3, and I have to divide the whole right side by 3. If I divide the whole right side by 3, that means the 4x would get divided by 3, and the 6 would get divided by 3. And I've now changed it to y equals mx plus b form. The nice thing about y equals mx plus b form is if you had to graph this, you already know the y-intercept is at -2. You already know the slope is 4 over 3, so it goes up 4 over 3, up 4 over 3. And you could find other points really quickly. So for graphing, y equals mx plus b is really, really nice. Same thing here. Can you see that you could add 2y to both sides to get the term with the y all by itself? And just what I sometimes do as mental math is I know that the 2y is going to be on the right, but I just right away write it on the left-hand side. Because it's going to be equal, so it doesn't matter which side is which. Then I need to divide everything by 2. 4 divided by 2, this will be 2x. 9 divided by 2, you can either change it to 4.5 or you could leave it as a fraction. Both would be fun.
How would you graph the 19?
How would you graph the 9 over 2? Then between 4 and 5. So as a decimal, it's a bit easier to visualize where that is. So sometimes we change things to decimals so we have a better visualization. So you would graph that y-intercept between 4 and 5.